This is conversion. First, I want to point out this is question 1A in section C. This is not hectometers, but you want this to be hectoliters. This is a metric prefix conversion, so I already have a review of that. But let's look at this is a conversion from the volume of water. So again, I'm going to have an example volume in the graduated cylinder. Let's say it was 15.5 milliliters. Now the graduated cylinder measures to this tenths place. That's because the markings on the graduated cylinder are the ones place. Okay, so the precision of the graduated cylinder should have been to the tenths place. And that was because the markings, so the precision is 0.1 milliliters. That's because the marks, the smallest marks, are the ones place. And the marks with numbers are the tens place. So 60 and 70, and then you have all the 10 marks in between. So what that means for the precision is that every measurement value should be to the to the tenths place, one decimal place out. So even if your measured value is right on the mark, right on 15, you would write 15.0 to represent that tenths decimal place. So this example volume, remember this is not in the lab, just came up with this number off the top of my head. We want to convert this volume and we want to convert this to gallons. So when you go look for a conversion factor, the conversion factor you will find one that converts from gallons to liters. So conversion factors you will find in the conversion factors in the lab procedure on page 7. You will find is that really page 7? No, that's page 7 of the total lab procedure. You will find it on page 1, 2, 3, 4. That was when I printed out all of them. So on page 4 or 7 of all. So this is, you will find that 1 gallon is equal to 3.785 liters. Okay, but we have the units are milliliters. So you also need a conversion factor with milliliters in it. And you're not going to find that in the equations, constants, and conversion factors on page 4 or page 7. This is because milli is a metric prefix and you need to generate a conversion factor with that milli metric prefix. So this would be milli, that's 10 to the minus 3. Make it a milliliter by multiplying liters onto both sides of the equality. Put a 1 in the front and this would be your other conversion factor. So anytime you have a metric prefix, you need to generate the conversion factor, starting with the power of 10. So now you can use both of these to convert this example volume number, so 15.5 milliliters, and then 2 fractions. On the bottom of the first one, you're going to choose 1 milliliter, and what it's equal to goes on the top, 10 to the minus 3 liters. So the reason why I put milliliters on the bottom was so I can cancel it out. The next units you have left are the liters. So I need to put liters down here. So choose the conversion factor with liters. This is 3.785 liters. And then on the top is the other side of the equality, 1 gallon. So what cancels out are liters and liters. And so the units you're left with are gallons. So leave some space, put gallons or GAL. And that's good because that's what we're trying to solve for. Once the units check out, then you can go to the calculator. One thing I don't have to calculate in is this 10 to the minus 3. I can actually pull it out and multiply times 10 to the minus 3. And the only thing that goes into the calculator is 15.5 and divided by 3.785. So this is, let's go 4. This is going to be 4.0951122285, and this is a number that on the calculator need to round, So going to the original number values, let's actually turn this to purple. This original number value 15.5 has 3 sig figs. So our answer needs 3 sig figs. So that's going to be the 4, the 0, and 9. There's a 5 after. So this is going to be 4.10, rounding up the 09. This is significant digits, the 4 and the 1, and the 0 is significant because it's a trailing 0 with a decimal. So zeros on the right when there's a decimal are significant. So this has 3 sig figs, and this would be the units of gallons. So that would be your answer.